Hi, welcome back to video number 6 of the summer work. And I'm going to start with these two problems that I printed out from CUDA. And one of the biggest questions I've gotten that really isn't addressed in our book is how to take a histogram without any data and go backwards to find the median or the IQR or any statistics that you might need from the graph itself. So I printed these two out because they have different numbers of values. The first thing I'm going to do is add up how many numbers are in each data set. And you can tell from the heights of the bars. So this is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This data set has 16 numbers. And when you have 16 numbers in your data set, that means that you will have 8 numbers below the median and 8 numbers above the median. And the median will be the average of the 8th number and the 9th number. So what I'm going to do is I'm going to count in 1, 2, 3, 4, 5, 6, 7, 8. And right here, if I go this way, 1, 2, 3, 4, 5, 6, 7, 8. Right here, if you can see, I'll zoom in so maybe you can see a little better. Right here on this spot on this bar would be where the median is. And when you have a histogram, you only have ranges of values. So our median, you can't really say what the exact number is, but you can say that it's between 500 and 999.9 repeating because it falls into this bar. Okay, now if you were to find the quartiles, it would be the same sort of thing. You would go 4 on either side of the numbers below the median and 4 on either side of the numbers above the median to find the quartiles. I think for the most part, you find the median only from graphs, but that's what you would do. So you would count 4 in, and quartile 1 would be right about there, and you would count 1, 2, 3, 4 in. And quartile 3 would be somewhere right around 1500. Okay, now on this one has a different number of values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. And in this case, you would have 8 numbers below the median. The median would be an actual value, and then 8 numbers above the median. So let's count in 1, 2, 3, 4, 5, 6, 7, 8. So the median would be the 9th number in, which would be this box here. Let me count from the other direction just to be sure. 1, 2, 3, 4, 5, 6, 7, 8. Any one of these 3 boxes is going to be the same bar. So our median would be between 1600 and 1699.9 repeating. And then same process for the quartiles. You would go 4 in from the bottom and 4 in from the top. Okay. Next thing we're going to do is use our calculator to figure out everything that we have done so far for this data set. So let me remind you from the last video, we had this data set of the birth rates of 10 countries. We calculated the mean, we calculated the median, we did a histogram. We stated that a value was a possible outlier. We talked about why the median should be used in this case and not the mean. And now, as I said, and how could I forget? We calculated the standard deviation by hand. And while I was calculating the standard deviation by hand, I told you guys that we probably won't do this by hand very often, maybe once or twice. Most of the time we'll use the calculator to do it. So that's what we're going to do next. I'm going to show you how to take a data set and calculate all of the statistics that we found so far, including some other ones. Okay, so the first thing we're going to do is go to Stat, Enter, and I already have all of my values in here for the data set that I want to use. And remember, if you want to clear this data set and type in a different data set, scroll up to the top of L1 so that that is highlighted, and then hit Clear, Enter, and you can clear out L1 to type in a new data set. But this is the one that I want. This is the same one from the last video. So you start with typing the numbers that you want into L1. And then you press Stat. Scroll over to Calc this time. We've only used things here so far. Notice you can also clear your list from the Stat menu. Go to Calc. And the one that we want is the very top one, which says one var stats, which stands for one variable stats. And we use one variable stats when we have just a list of numbers. And it's going to ask you what list you're using. I'm using L1. And you want to make sure that you don't have anything in your frequency list. This is going to be in chapter 6, not chapter 1. So take out anything that's in the frequency list. Make sure that this is blank. Make sure this is says L1. Just a reminder, if it doesn't say L1, L1 is above the 1 on your calculator, and you can access that by hitting second and then 1 and hit calculate. And all of the statistics that we have calculated so far by hand were done in about 1 second. Let's talk about what all of these things are and what we will use them for. So this first one is the mean. I explained about the symbol for X bar. And I believe that I rounded that to 2.53 in the last video, and we were using that. So that's the mean. This is capital sigma of X. And that's the sum of all of the numbers added together. Capital sigma of X squared is the sum squared. And you could see why that might be useful from our standard deviation calculations, except the next one that they give you is the one we calculated by hand. And I'm going to round this to 1.66. This is sample standard deviation. And I'm going to remind you that we calculated this by hand. In the previous video, there is the answer of 1.66. And this verifies my answer of 1.66 from the calculator. Okay. Next, we have lowercase sigma x. This is population standard deviation. And this one is the same calculations except for they divided by n instead of dividing by n minus 1. N minus 1 is a little bit more of a conservative estimate because it's a sample. And then it tells you n is 10. That's how many numbers you have. So the number of data values. the min, and then scroll down on your calculator and you'll get the quartiles and the median and the max. Okay, and these 5 at the bottom are very important. Those are called the 5 number summary. And those 5 are the values that we use to make box plots, which we are going to use in just a minute. Okay, that's everything off of one variable stats. And all of those things should match the values that we found before. Hold on, let's just check. 2.58, 1.77. Yep. Everything's correct. Before we get to box plots, though, we're going to come back to identifying whether or not 6.89 was actually an outlier. So when we first graphed it and I first showed it to you, there's a gap, and you could see that 6.89 was pretty far from the rest of the data values. And I told you, as a spoiler alert in the last video, that it probably is an outlier. But there's a very specific process that we use to determine whether or not something is an outlier in a data set, and it's called the 1.5 times IQR rule. All low outliers are below quartile 1 minus 1.5 times IQR. Hold on. I got really excited about writing the Q. And all high outliers are above quartile 3 plus 1.5 times IQR. Okay, example, identify any outliers from the data set from the last video we did. The first thing we need to do is multiply 1.5 times the IQR. So going back to the last video, we calculated the IQR was 2.58 minus 1.77. So the IQR was 0.81. You can also get those values off of your calculator now. 2.58 minus 1.77. And 1.5 times the IQR, quartile 3 minus quartile 1, is 1.215. Okay, so the low boundary is going to be quartile 1 minus 1.5 times IQR. Quartile 1 was 1.77 minus 1.215. Which is kind of satisfying, 0.555. And this is your lower boundary. Okay. Were any numbers in our data set below 0.555? Let's go look. Nope. Our min was 1.33. So that means there are no low outliers. Okay, high outliers are above quartile 3 plus 1.5 times IQR. Quartile 3 was 2.58. 3.795 is our upper boundary. Did we have any values in our data set that were above 3.795? Pretty sure there was. Because I remember thinking it was crazy that on average that they had almost 7 kids in that country. Yep. We also had 3.54. That one's not quite an outlier. Okay, so our only outlier is 6.89, which is not surprising. We figured it was from the gap in the histogram. Okay, so we determined that my data set had no low outliers, but that it had one high outlier at 6.89, which is not really shocking because we saw that gap and I happened to tell you in the previous video that it probably was. So what we're going to do now is I'm going to go back to soft and I need to update this. First of all, I'm going to cross out the word possible. Because I did the 1.5 times IQR rule and I showed that it was a high outlier at 6.89. And then I never filled in the spread for this, which is actually okay because we need to work on box plot today, and that's where you would probably find the spread. In this case, because I used the median, I would use the IQR for spread because IQR is not resistant or is resistant to skew and outliers, which is why I liked it. And I already calculated it right here, 0.81 births per woman. So just a quick note, if you're choosing the median, you want to choose IQR for your spread because IQR requires the median to calculate it. Okay. So now I have gathered a new data set for us to kind of just check to make sure that we understand what we're doing. We're going to create a combination histogram box plot. And this is going to be our first time making a box plot off of the 5-number summary. And we're going to calculate whether or not we have outliers and fully describe the distribution. All right. The first thing that's actually probably the hardest thing is to figure out your scale. And I'm going to sort of wing the y-axis. I know that needs to be frequency. And my x-axis, I noticed that it starts at 2,300-ish and it goes to almost 4,000-ish. So I'm thinking that I'm going to start my y-axis at 2,200 and then go by 200s. So I don't have way too many boxes here. Okay, so I went below my lowest number and I went above my highest number, and that's not a crazy amount on the x-axis. And I'm going to write car weights in pounds. And then on the y-axis, I'm going to go by ones as we do for histograms and write frequency. Okay, so there's my setup. And this says create a combination histogram box plot. So I'm going to start with the histogram. I'm just going to do that part by hand. Um, I have one value in the 2300s. I have one value in the 2600s. I have two values between 28 and three values between 28 and 3000. I have one value between 3000 and 3200. I have two values between 3200 and 3400. I have one, two, three, four, five values in between 3400 and 3600. I have one value in the 3600s and then two values in the 3900s. This is a little bit of a different kind of shape. That's okay. Okay. When you describe a histogram, we've been working on this in 3 videos now. Shape, outliers, center, spread. And this shape is really strange. I'm going to ask the people in the room to look up at this picture and tell me what you think this shape is. I hear just about every possible shape being thrown out there. I was going to say roughly symmetric. Okay. I see what you're talking about over here with the possible tail. I don't know. This one is a weird one for sure. Um, okay, you guys can go back to your regularly scheduled activity. But for the other things, I am going to utilize the one variable stats on the calculator to help me find my center, my spread, determine if there's outliers, and then I'm also going to use it to help me make a box plot. So this is very, very powerful information. So stat, edit, and then I want to type these numbers in. So I'm going to scroll to the top of the column and hit clear, enter. And then hopefully I'll type them in correctly. No pressure. Okay. I have everything crossed that I did that right. Okay, so I can actually check, but that's not super important here. So let's go back to what I taught you to do at the beginning of the video. Stat, scroll over to calc and choose one variable stats. You want to make sure that your list is L1 and that you don't have anything in your frequency list. Okay, so there's the mean standard deviation, which is what I'm going to choose for my values of center and spread. Actually, maybe we should do the outliers check first. How about we do that? Okay, so 1.5 times IQR. Scroll down in your one variable stats so you can find quartile 3 and quartile 1. So 1.5 times 3,545 minus 2957.5. 881.25. Okay, so for the low outliers, I'm going to do quartile 1 minus this. Quartile 1 was 2957.5 minus 881.25. 2,076. Okay, so now I check back up in my data values and I say, were there any data values below this? No. So there's no low outliers. And I feel like there's not any high ones either, just from the shape of this, but we have to check. Okay, for high outliers, you take quartile 3 plus 1.5 times IQR. And you get 4,426.25. Then I check back in my data set. Are there any numbers above 4,426.25? No. No high outliers. And I'm not really surprised from my shape, my histogram there, that other evidence to show me that I probably don't have any outliers. And that's a good thing. You don't want outliers. That usually means there's something wrong with your data. So don't feel like you have to put something there. None is the best answer. If you have something that is symmetric with no outliers, then you want to choose the mean as your center. One of the annoying things about the calculator is it will take all of your stats away. So I just scroll up to my previous command of one variable stats and hit enter to do it over again. Make sure that you put units on your center. I put pounds. And if you choose mean, you want to choose sample standard deviation. This is a sample of cars, so I'm pretty sure this is not all the cars in the world. And I'm just getting this number straight off the calculator instead of calculating it by hand like I did in the last video. And these two go together. X bar and S of X go together. Okay, so now I have my description. The only thing I'm missing is the box plot. And I have all the information for the box plot also in one variable stats. I just need to scroll down to the bottom. And what you do is you put vertical lines at each of these 5 spots. So 2,310 would be like right here. 2957 would be like right here. 3380 would be like right here. 3545 would be right here. 3945 would be like here. From your 5 number summary at the very bottom. And I usually connect my box like this, and then I will go out to the sides for the whiskers. So there is my box plot off of my 5 number summary. Okay, so let's just check back in. I created a histogram. It's easiest to do that by hand and not in the calculator. Then I went to the calculator to find my statistics after determining the shape and if there were outliers. It was roughly symmetric with no outliers, so I chose the mean and standard deviation as my measures of center and spread. If there had been skew or outliers, I would have chosen median and IQR, like the last example. And all of those things are found in one variable stats. I labeled my axes and I labeled my units. I can pretty much guarantee you that there will be a problem exactly like this one on your chapter 1 test. So you should make sure you know how to do this very well. Okay. We have one more thing for us to write, and then I'm going to show you something else on the calculator. And I want to talk about what happens when you compare box plots. So in some of the FRQs, they're going to have 2 graphs. Sometimes they're histograms, sometimes they're box plots, and they're going to ask you to compare them. And I want to give you the very specifics on what College Board wants for when you're making comparisons between 2 graphs. I have a picture pulled up from our textbook. This is a problem out of our textbook. Notice that there are 2 box plots right next to each other, and it's Apple phones and Samsung phones. I don't even know. Oh, ratings, apparently. And it says compare the distribution of overall rating for Apple and Samsung. So I want to make sure that you know the requirements that I'll be looking for when you're comparing 2 distributions. When you compare 2 distributions, you're still going to do SOCs. You're just going to do it in a very specific way. For this shape, you're just going to state the shape of both box plots. In the case of the example that we were looking at, I would say a sentence something like both the box plot for Apple and Samsung are left skewed. And you can tell that they're left skewed because the tails and outliers are going to the left direction. Okay, for outliers, you have 2 possibilities. If you have a data set, do the 1.5 times IQR rule for both data sets and state all outliers. And this is if you have a data set, or estimate possible outliers from the graph. And this is a really great example of that on this graph. Notice the Apple data set has 2 low outliers. Because we have the data set, we can tell that those are 73 and 76. And then my box plot actually starts at the next highest number, which is 79. So you can really see how you make that box plot if there are outliers involved. And if you have the data set, you can state what the outliers are, or you can estimate them based on the location of the stars in the box plot. Either way, you can tell that Apple has two low outliers, one at about 73, one at about 76. Okay, now for center, if either distribution has skew or outliers, compare the medians. Even if one of them is symmetric and the other one is askew, you have to compare the same statistic either way, so it defaults to median. Any skew or outliers involved with any of the graphs or data sets, you go to median. And when you're comparing them, you need to use comparison language, like higher, lower, more than, less than, compared to, just, or only. For the spread, oh, let me go back to my example. I would say something like the median of Apple is slightly higher than the median of Samsung at 84 versus 83. And I can get those numbers from the statistics down here, and I can get them from the middle of the box plots here. And for spread, you want to use the IQRs. And then use that comparison language as well. Okay, for example, something like the IQR of Samsung is much larger than the IQR of Apple at, and then you would subtract, this would be 11 versus 3. Something like that. But using those comparison words and using the statistics that you have provided for you or the statistics out of your example, refer to the numbers and write the word versus in there for full credit, making sure you're referencing the numbers also. The last thing I'm going to say about this is units. Always include unit. And I added that to my paper. Use units for everything, all throughout the whole thing for full credit. You just never know when College Board is going to care about the units and when they're not. So always best to use the units for every single thing. Okay. Very last thing I want to do for you is show you how to make a box plot on the calculator. And we use this much later in the school year. But for now, it has some use. You saw how easy it was for me to make a box plot by hand with the one variable stats. But I also want to show you on the calculator just so you can see it. The first thing I'm going to do is make sure that my data set is included. So this is the data set I want to use. And I'm hoping that my box plot is going to look a lot like this box plot I already made. So let's put this next to this so we can make sure that they look the same. And I just typed something in there that I didn't want. Okay, so I'm going to go second y equals. Second y equals, if you notice above it says stat plot, and look at all of the options that give you all different types of plots for stats, and hit enter on the first one. I'm going to turn it on, so hit enter on top of on, and then I'm going to scroll over to the box plot, which is the first one, which has the dots. So your calculator has two options. You can show the outliers or not show the outliers. I always choose the one where it shows the outliers because the calculator does the 1.5 times IQR rule, and you can use that to check your work. So I'm going to hit enter on top of that. And it says, what is the X list? The X list is L1. That's what I typed it into. And then I'm going to put, I want to graph it in the best way for stats. So you hit zoom, and then notice number 9 is zoom stats. So zoom, and then the number 9. Hey, my box plot looks pretty good. The one I did by hand looks pretty much like the one from the calculator. And you might wonder how that's useful to you without any values. What you do is you hit the trace button, which is right next to the zoom, and you can scroll back and forth with your arrow pad and confirm the min, quartile 1, the median, quartile 3, and the maximum. And then for the last thing, if I want to get fancy, I could see what, hold on, let me turn this off. See what I could get with a histogram. Notice my histogram is not exactly the same. So if I change my window, there it is. Look at the beauty of my combination histogram box plot. Can you all look at the beauty of my combination histogram box plot that I made on my calculator that matches the one on my paper? Oh, the flawlessness of said. Now, as I said before, I will probably never make a histogram on the calculator. It takes more time than to just do it by hand. But if you're a person that likes to mess around with the calculator, by all means, go ahead. Okay, everybody, this concludes video number 6. And I will catch back up to you for video 7, which will be the last one. Thank you for listening.